Welcome to a week in astronomy, or the things I found interesting in the world of astronomy this week. First up, a little send-off for the Spitzer Space Telescope, which has been announced that it's been retired this month, sending its last bits of data as January draws to a close. The Spitzer Space Telescope has been working in the infrared for many years now to improve our understanding of the cosmos. For some good examples, there's surveys called GLIMPS and MIPSCAL. They're surveys to create an infrared map of the Milky Way in multiple wavelengths of infrared. I'll link to a viewer of them in the description. It's absolutely stunning, the quality that we have there. Other things that it's done, it led to the discovery of the Double Helix Nebula, which is believed to have gained its shape from strong magnetic fields in the central solar system causing torsion. On a close to home note, it found the Phoebe ring, a nearly invisible ring of Saturn located near its moon Phoebe. It observed the first light from exoplanets, the hot Jupiters HD 209458b and TRES-1b. So we'd observed exoplanets, but that was the first time we actually got light from them rather than inferring their existence from the properties of the star that they were orbiting around. In later years, it was also configured as an exoplanet hunter. For example, the TRAPPIST-1 system, which is now very well known in astronomy, it found 5 of the planets around that. And in its later years, it's been used to look for interesting candidates for the James Webb Space Telescope, which will be the next big thing in infrared astronomy. But all good things must come to an end, and Spitzer is no different. The basic problem they have is this. Spitzer needs to be moved to angle its solar panels to the Sun and its antenna to the Earth, which you need to communicate, and it needs to angle its telescope to wherever you want to look at. It's in an orbit which is in effect trailing behind the Earth, with the distance increasing, and the angles you need to move to do this getting less and less easy. You're relying on the amount of solar power that you gain from angling your solar panels at the Sun, keeping up with the amount of effort it needs to move and transmit data to Earth and record data. As operation was becoming more and more difficult, the decision was made to end the mission in a controlled manner. The telescope was planned to cease operations last year. However, delays to the James Webb Space Telescope caused a rethink, and they decided to carry on observing a bit longer. You see, the original plan was for JWST to launch in 2018, and you could have a period of time where both telescopes were operational. But with that plan gone, Spitzer was kept for a while longer. So goodbye, Spitzer. You did so much, and so much more than those who first made you may ever have dreamed of. Another little story which caught my attention was baking cookies in space. It's a story from late December that for some reason started doing the rounds around this week. It's short, but it leads to interesting things. So here it is. Astronauts on the International Space Station made cookies. They packaged them up and sent them back to Earth for analysis. But the interesting thing is they took a long while to cook. So instead of around 25 minutes to half an hour, they were needing to be cooked for about 2 hours. Now, what caught my eye was not just, it's an interesting result, but a line in a news article about it that said they were the first food baked in space from raw ingredients. Now, some of this may be in the wording. There's plenty of food that can be made without baking, but it's quite a bombshell that in over 50 years of humanity in space, we can still say that. It ties in with thoughts about humanity going to space long term, setting up permanent bases on other worlds, and the ability to cook is one thing we'll likely need from that. The fact we're still at the early stages is rather worrying. Going wider then, how many vital parts of long-term space occupation haven't we even tried yet? There's an interesting article about providing medicine in space, which I'll link to. It's called Supplying a Pharmacy for NASA Exploration Spaceflight, Challenges and Current Understanding. What it points out especially is the lack of knowledge in a lot of areas just about basic keeping people well. A lot of our ideas on space medication seem to just be based on hoping like hell it works just like it does on Earth. In other areas, unless there's some secret Soviet experiment I'm unaware of, I don't even think we've had sex in space. With taken some medication but haven't dealt with more severe health problems. We certainly haven't had to deal with getting old in space, and how space travel for a really sort of long time, we're talking 10, 15 years maybe, impacts someone. And it's quite worrying if we think we're going to go into space long term. We'll be putting people elsewhere for maybe the rest of their lives if we haven't had anyone age in space, if we haven't done so many things that are important to humanity. But on the other hand, the reason why is fairly simple. There's a rather cute little interesting site called howmanypeopleareinSpaceRightNow.com, which does what it says in the name. I'll link to it. The answer is 6. 6 people. That's all we've got. And that's the reason why we haven't made much progress. Just simple manpower. We could do a far better job documenting the medicine our astronauts use. In fact, we're making some progress in that area. But it takes up crew time. We could get better ideas for the health effects in space for, say, older people, or for people taking far longer in space than our usual few years. But that sacrifices the other scientific work, which needs our astronauts selected from a very fit and healthy subgroup. So, actually, a small story about astronauts having some trouble baking cookies really helps highlight just how close to the space colonisation start line we still are. So that's all for this week then. Goodbye, and I hope to see you next week.